All right, so 1.5, number 6. All right, I like this one because it really drives home the importance of thinking about your time intervals, okay? And I think that a drawing will help you kind of organize your thoughts, okay? So number 6, it says a car driving at 30 meters a second stops in 6 seconds. A, you had to find the acceleration. I'm assuming most people were good with that, but I'm going to run through it because it'll kind of draw attention to some things that I want to think about. All right, so you've got a car driving along. So here's our car. Driving along, velocity of 30 meters a second. And then now it is stopped. That takes 6 seconds. Over here, time is 0. All right, everybody good? All right. So part A says, what is the car's acceleration? So for part A, we want to find the acceleration. We know our initial velocity is 30. We know our final velocity is 0. We know the time is 6 seconds. We know acceleration is Vf minus Vi over t. Plug in your numbers, and you get negative 5 meters a second. Everybody cool up to there? Did I do that too fast? Is that a hand up, Ada? Ada, right? Yeah, okay. All right, is everybody happy with A? All right, now notice, you guys, this acceleration applies to the whole problem, right? The entire time the car is slowing down, this is the acceleration. So let's make a note that we know this acceleration, because it's going to apply to every part of this problem. Clear? All right, so that's that. Now, part B. Part B says, if I remember right, what's the velocity after 3 seconds, right? Part B, what is the velocity after 3 seconds? So the idea is, we started at 0. After 6 seconds, it stopped. Somewhere in the middle here, the car is somewhere after 3 seconds, right? And the question wants to know, what is that velocity, right? So question B is specifically asking for, question B is asking for the velocity at the end of that yellow time interval. Does that make sense? All right, so what else do I know about that yellow time interval, you guys? Just shout some stuff out. What else do we know? Cool, we know the acceleration because we found that in part A, right? What else? At the start of those 3 seconds, our velocity is 30, right? And there's one other thing we know. The time is 3 seconds, right? Everybody good up to there? Okay, so now we want to find an equation that allows us to do that. This is an equation we're going to use a lot this year, so just get used to it. Vi plus At. So you get 30 plus negative 5 times 3, and you end up getting 15 meters a second. Which kind of makes sense, right? That it would be halfway between 30 and 0, right? In half the time, you're going to have half the change. Cool? All right, so put that on your drawing. Oh, I just figured out the velocity here. It's 15. Oh my gosh, undo. This always happens to me when I use the highlighters. Put it on your drawing. All right, everybody good? All right, part B says, how far does the car go in the first 3 seconds? Or sorry, part C. Part C says, how far does the car go in the first 3 seconds? So part C, notice, you guys, this is important. Part C is the same time interval as part B, right? The only difference is now we're looking for what variable? Displacement, right? So notice, to do part C, I know I've already got this. Well, here, let me write it down. Here's what we know about the yellow time interval now. We know our starting velocity is 30. We know our final velocity is 15. We know our acceleration is negative 5. and we know our time is 3 seconds, right? So that's the stuff that we know about part C, about the yellow time interval, right?
Yeah.
All right, and we're trying to find displacement. So at this point, you can use any of the, in the video, there were 3 different ways that you could find the acceleration of an object that's accelerating, right? Okay, you can use any of them in this. You can do half of the acceleration times time squared plus VIT, right? We know our A, we know our T, we know our VI. You can do 1/2 of VF plus VI times T. We know all our numbers there. Or if you want, you can use some algebra. I probably wouldn't go this route just because it's a little bit more complicated, but it does work, right? Do you guys agree that any of these 3 equations will get it? Okay. And so when you find the displacement, using any of these 3 equations, you end up getting 67.5 meters. Everybody good up to there? Problems, questions, concerns, anything? All right. So that's part C. Now, I guess I should really quickly comment, you guys. When do I need to use these displacement equations instead of just doing velocity times time? Good, when the object is accelerating. Everybody good with that? Like, that's what complicates things, is the fact that the object is accelerating. So it goes a different distance in, each second. No, you're okay. Just don't trip on things. All right, everybody good?
Yeah.
All right, so part D wants to know how far it goes in the last 3 seconds. So part D wants to know between here and here, how far does it go? Okay, so for part D, let's write down what we know. I'm assuming part D is where everybody struggled, yeah? It's not. All right, so what do we know about part D? What's our given information? Good, we know our acceleration because we found that in part A. We're trying to find out how far it goes during the last 3 seconds. So my time is still 3 seconds, right? Why? Let me ask you guys this. Why isn't it the same as C? Why doesn't it go 67.5 meters again? Sure, we got it.
It's already slowed down. It's not as fast as it was.
Exactly. At the beginning, it's going very fast, right? Because it started out, it was going 30 meters a second. By the end of these 3 seconds, it's slowed down, so it's going to be going less than 15 meters a second, right? Follow? Okay, so what else do we know? We know 2 other things. We know our initial velocity is it 30? Look at the pink, purple colors. It's magenta. Look at the magenta time interval. At the start of it, it's 15, right? And final velocity is 0. So now you can use that given information along with one of these equations and solve it. And you end up getting, I think it's 22.5 if I remember right. Yeah.
Can I just find like the displacement when it's 6 seconds? And subtract?
Do the whole thing and subtract 100%. Yeah. 100%. Okay. Does this make sense, you guys? Do you see what I'm talking about? How I kind of used the drawing to keep my information organized? Right? Like I identify points, and at each point I'm writing down how much time has elapsed and what the velocity is at that point. Very, very common problem solving strategy, okay? You guys are going to see me do this again as we go through other problems here. All right? So draw the path the object follows. As you discover information about points, at those points, write down the time and or velocity if you know that. Good? All right. Anything else you guys want me to say about number 6? Okie dokie.